Hello, everyone. Welcome to Business Public, a podcast that explores the intersection between the public sector and businesses in the digital age. I'm Larissa Muse, and I'm your host today. As our first guest, we have Dr. Gao. She is a senior research scientist and assistant director of research at New York University's Connected Cities for Smart Mobility towards Accessible and Resilient Transportation, also known as C2SMART. And she focused on smart mobility and traffic analytics, right? With a particular emphasis on connected vehicle systems and data-driven mobility. She is well known for her evaluation role of the US DOT Connected Vehicle Pilot deployment in New York City, and for her work on AI solutions to improve traffic safety and manage congestion. Before her current position at NYU, she specialized in modeling and data analytics at the New York City Department of Transportation. Isn't that right?
NYC DOT.
Welcome. Welcome, Dr. Gao. May I call you Jannie?
Yeah.
Oh, wonderful. So I want to start with your background and the mission of your organization.
Sure. First of all, thank you for inviting me, and I'm actually super excited and honored to be, the first guest of the US series of Business Public. And as I think you introduced, I'm currently the Assistant Director for Research at New York University C2SMART University Transportation Center. So our center C2SMART initially back to 2016 was established as a U.S. Department of Transportation, U.S. DOT funded University Transportation Center. And just give me a little bit of background of, what this UTC means. So it is a program that funded by the federal government in U.S. and U.S. Department of Transportation in terms of facilitating, the state-of-art development of transportation technology, as well as the development of next generation of transportation professionals. So that's kind of, the university role in terms of that. And in the U.S., we have about 35 this kind of centers. And there's basically a selection every 5 years for these centers, and each UTC is actually a consortium of universities. So it is not just New York University. Mm-hmm. We, for example, C2SMART, when we started, we have 5 different universities across the nation under the consortium of C2SMART, and that I think is a great pathway, to facilitate like mutual interest, mutual understanding, and of course better technology, transfer. And each UTC has a specific research goal. So for C2SMART, for our center, our research goal is improving the mobility of people and goods and reducing congestion. And we have different threats area, but the core mission of our center is really to develop and deploy innovative technologies, and to build evidence-based, solutions, practical solutions, and to try to address some of the most pressing mobility and safety challenges, especially within the urban, environment. And as the assistant director of the center, my role is mainly to lead and co-lead, various of collaborative projects. A lot of projects we have collaboration with, federal agencies, with different organizations, including state and local agencies, as well as our industry partners, to facilitate, I think, a more collaborative, development, and I said, like testing, deployment, and transformation of the new technology. I'm always very excited about the things that we're doing, because they are kind of on the cutting edge of a lot of, interesting technology. And also we work a lot with community as well, the end user of the transport system, to understand, the actual needs, from the group of people who are going to benefit from all these technology development.
That's wonderful. So some of our audience may not be as familiar with C2SMART, so thank you for introducing what you are. I've known this center for the longest time, about 7 years ago when I met Professor Khan. I know that this center has become a reference in smart mobility, not only for among the other universities, among the other DOT centers, but among the industry in general. So can you talk about what makes C2SMART successful in that area?
Oh, definitely. And this is really related to the slogan that I love most from our center. We call it, we want to use cities as living labs. And I think that's the most successful part of, not only to think about, we're developing algorithm, we're developing solutions. It's more about, first of all, talking to, different sectors when developing this technology. Second is understanding what is actually happening, in the real world. Because in academia, a lot of times, especially I think in the old times, a lot of things like we make assumptions, right? Like if you're using statistics model, we make assumptions. But it may not be true in the real world of these are the actual needs from the end user, from the agency partner of like what they want to, like what kind of tool they want to build. So using cities as living labs actually allowed us to pilot testing a lot of the new technologies at different portions of the city. We have physical test bed, like we have a physical test bed at one of the important highway in New York called Brooklyn Queens Expressway, BQE, to, look at like overweight trucks and information. We have like cyber physical test bed that we built, that has like VR simulation tools, for like worker safety, work zone safety. We also built like purely, cyber test bed, like digital twins, AI digital twins, to say if we want to test some of the things, it's hard to test in the real world, but it's so connected to the world. For example, like ambulance, emergency vehicles. So one of our projects is actually working with, New York City Fire Department to look into if we can build a virtual test bed, digital twin of their operations. And all of these innovations, if successful, will really ultimately lead to life-saving and, more efficient transport system. So I think that type of idea of living labs and also make it easier to transfer all these knowledge and information that we develop to, let's say, another university under our consortium, or to transfer to another city, if they want to do a similar stuff. And I think that's the most successful part of C2SMART.
That's exciting. Actually, I have been accompanying your career, not only C2SMART, but your career for some time now. And I know that you have worked with several projects that were very successful and very interesting as well. So can you tell our audience about them and which one was your favorite?
Sure. So I think the first one that came to my mind is definitely this, connected vehicle pilot deployment, which is a pilot program, I would say, initiated by U.S. Department of Transportation, by the federal government. And basically, U.S. DOT selected 3 different test sites, including Tampa, Wyoming, and New York City. And of course, New York City is, I would say the largest, the deployment site with the largest number of, connected vehicles. And for some of you, if you're not familiar with connected vehicle technology, basically this technology enable vehicle to vehicle communication, vehicle to infrastructure communication. So basically vehicle can talk to vehicle, or vehicle can talk to, traffic lights, can talk to pedestrians, and if any dangerous situation is, detected, such as running red light, and such as, emergency brake, like things like that. So our team were lucky to serve as 2, I would say, important roles in this connected vehicle pilot deployment. This is a project that all the way back to 2016, and it was there for, I think, like 5 years until 2020, 2021. And one is our team will serve as the safety evaluation team to look at, the safety effectiveness of all of these applications that developed using connected vehicle technology. Because deployment is not, is one thing, but evaluation to prove to say this new technology is working, right? It's saving life, it's reducing risk, and it's more important. So we spend a lot of time, a lot of effort to actually evaluate. There's like 14 different applications, and most of them are like safety related applications in the New York City. Pilot with, all the support and, help with New York City Department of Transportation. They're the main player, in that pilot. And we were actually successful to using, advanced safety assessment technologies, some real world data, some simulated information, to prove some of the applications is actually having statistically significant, benefit in terms of safety, such as red light running alerts and speed compliance alerts. And think about 10 years after that, now we are actually seeing a lot of these technology, being used, in the actual car manufacturing. So all of the new car model that we see in the market now, what they call it is advanced driver assistant system, ADAS, and everyone probably experienced that, blind spot alert, right, with the cars. So these are all new technologies that are proven to be effective in terms of improved safety. And another interesting part of that project, I think, is this: we also serve as the lead team in terms of piloting a pedestrian mobile phone application for people with vision disabilities using same technology, connected vehicle technology. And in that version, what we do is we make the mobile phone talk to the infrastructure, talk to the signal, talk to the geographic alignment of the intersection. So to provide haptic or audio alert to help people with vision disability to safely cross the street. And we did a user survey at the end, and they were actually saying this is a game changer, for some of them, if the technology can be deployed widely.
So impactful.
Yeah, I think it's very interesting project, and it's the best example from my experience of understanding the end user's needs. Some of them, their feedback were actually used to better design the application of how the application functions. And it's also great, I think, example of, industry and academia and government collaboration in terms of that, because you, of course, have the vendor developing the app and having the academia team to do evaluation, tests, field tests, and everything. And the government agency, of course, providing support in terms of their infrastructure and knowledge. And one more example, I think is very timely, is we've been talking about this for multiple times, as well as we've been doing a lot of AI computer vision, approach. And of course, computer vision technology has been widely used in the past, I would say 3-4 years in different aspects of the world, and in transportation domain, and in addition to, all the regular use in terms of counting vehicles. And our team is actually exploring the usage of computer vision to some very interesting cases, such as airport landside traffic. Because think about when you go to the airport, I think the most interesting part is people behave so differently. Thinking about the demand on the curbside of a terminal is always driven by the departure, arrival of the flights. And then people tend to have more activity, more dynamic activity, even on the moving lane, loading, unloading luggages, right? And even there's lane marks. People tend to form their own lane. Drivers tend to form their own lanes at the airport environment. So this is very different. And we were pretty lucky to collaborate with a local agency, Port Authority of New York and New Jersey, to look at JFK International Airport, to look at one of the terminals using their existing videos. And I think that's very interesting case to look at. And also help understand, how complex and different, this airport environment looks like. And of course, we use computer vision for, the reason why I say timely is for, the upcoming World Cup. So we were able to, collaborate with NJSEA, New Jersey Sports, Exposition Authority, and the MetLife Stadium. And if people know that, and this is the venue for hosting the final of the upcoming World Cup. So we have some AI cameras over there to look at the dynamics of attendees, for egress and ingress of large event. And again, the dynamics of large event is also very different. We have a lot of observations, manual observation in the past, and people know some of the conclusions, but I think the camera kind of making it possible to think about, hey, here is the quantitative, evidence of information from 10 different large events, on different time of day, different day of week, and how people move as a crowd, not as individual people, but how people move as a crowd. And those are the information that was not available in the past, with
verifiable information that you can actually check after all and design policies based on this.
Exactly.
Fantastic. Yeah, it's impressive how this technology. Oh, sorry. Before we move forward, I asked which one was your favorite.
If you ask me now, I would definitely say this World Cup project. I mean, it's not super. It's not like directly for World Cup, but it's for the preparation of large events. But if you ask over my entire career so far, I would say the connected vehicle definitely is my favorite project.
Oh, that's fantastic. I'm glad to hear that. As I said, I have accompanied the work of C2Smart and your career. It's so interesting to see how over the years the technology has evolved, but not only the technology, the means to, implement those projects, because the larger they are, the most impactful they are, also comes with challenges, right? So
definitely.
I wanted to ask you, based on your experience, not only these projects, but on C2Smart, but before, what are the main challenges and pushbacks that you have encountered in implementing them?
So there's a couple of things that I think kind of raise, not say a red flag, but kind of making me think about this is important lessons learned, from our past experience. One is definitely, as you said, there's a lot of new technology coming up, and the dynamic and I think the speed of iteration of the new technology has also become faster, much faster than we saw it before. And so that comes with a byproduct or a new problem is the technology obsolescence. And we've been experiencing some of those challenges in terms of even the connected vehicle pilot project that I mentioned, because the time spent of, such pilot deployment, and that's one of the lessons learned is to make the time span actually shorter for pilot deployment. It's longer than 5 years. And then, there's new technology coming in, doing the development of the project, the technology, but that kind of raised a concern to thinking about, the accountability, reliability of deploying new technology. And I think in the planning frame, it is important to actually plan for that, to say we should, plan for a backup plan B if anything happens, or we should make some checkpoint in the middle to make sure, and this technology obsolescence is not, stopping, factor of the project. But just to be honest, a lot of times, this might be out of the control of the project team, right? It can be because of the entire, environment or market of the technology. But also it can be coming from even high level, the ruling or the requirement of how to use technology. Think about the example of all these new automated vehicle, and drones, permissions for drones. So that's something I think kind of come with new technology, and it's a byproduct that you cannot avoid, but it should be a problem that needs to be aware. And another part is definitely, I won't really call it a barrier, but because actually there's a lot of progress and good, improvement in terms of that. But definitely this institutional, challenge, even for a good collaboration between government agency, the public sector, private sector, and academia, there are always certain challenge in terms of, the gap of understanding, vendors or companies build a tool and saying these are the useful functionalities. But when you talk to academia, we may build very advanced algorithm that we think, these are the most, these are the smartest algorithm in the world, and we're very proud of developing all of these. But then to the practical side, for the actual deployment of the technology, if you want to use it in the near term, there always come with very realistic problems first of all, of course, is this fitting the needs of what the agency is looking at? Is this fitting the needs of the end user, what the end user is looking for? And also, is this fitting the needs of making it a practical solution? Because a lot of advanced technology might not be, immediately deployable because of that. But there's always, segues to make it work. So I think that kind of mutual understanding, and also a lot of times we develop the tool without knowing, what agency actually needs, and pitch the idea or match, I would say the capability of the academic team and the capability of the industry partner and the speed, they can develop new product and the actual needs for agencies. And of course, for agencies, the gap is really, they may not have, enough like labor in-house labor or capacity right to achieve what they want to achieve. So I feel like there's a natural kind of relationship to say, let's use the brain, let's use the bandwidth or capability of the industry partner, of the academic partner, but also the directions like for agency partner, public sector. It will be good to get like periodic feedback from them to understand like if we are on the right direction, if we are not like spending time doing duplicated efforts, right? And this is not only for, let's say, New York City, and there's sometimes we see like duplicate efforts for multiple cities like doing similar stuff, and they might not be aware of what they're doing,
not communicating. Yeah.
Right. So I think like better like visibility of everyone's ongoing research or efforts on testing those new technology, talk to peers about what you're doing, what they're doing, and share the lessons learned, share the knowledge from everyone. I think is very important to make everything more successful. But I've already seen a lot of progress, as I said, in the past 10 years. We've been struggling a lot in the past, like on data sharing. But now if you look at what each US cities are doing, so for most of the major cities and states in the US, now you will be able to find this like open data portal. Mm-hmm. That is basically, sharing the data from multiple like government agency within the city for information. And I was like, that is something that was not super successful, 10 years ago, but now everyone is making it a new standard of sharing data. And that definitely facilitates the entire, I think, interest, encourage, more collaboration, more research, and more interest in helping the city doing better jobs.
We understand that if you don't have the right stakeholders in the table, the project might not move forward, right? Mm-hmm. But I also notice in many of those projects that you have a collective, everyone that is putting technology on the city are collecting an enormous amount of data, right? So when you have that, when you deploy these new technologies, data governance then becomes a significant concern for cities, especially those that might not have the personnel that are qualified to identify those shortcomings on the technology or those risks, right? Especially when in regards to privacy, cybersecurity. So what's your take on this matter, and which policy considerations should city officials consider when deploying these smart technologies in the public space?
Definitely. So I think, privacy protection, first of all, is definitely the most important, part of data governance, especially with all these new data coming in and now with much more detailed information. And thinking about, especially in the transportation domain, I think travel information, mobility information is actually very personal, details. Mm-hmm. For example, in the past, we're only doing traffic counts, but now you have trajectory of the vehicle. Now you know the origin destination of the vehicle, right? And you have camera data that sometimes, there are people worrying like, oh, I'm recording the faces, from the video images. And I think the privacy protection, from my aspect, I would say, it needs to be considered in every stage of, developing a tool or conducting a project. And of course, there's this once you collect the data, there's ways of obfuscated the data, doing anonymized, encrypted data. For example, in connected vehicle pilot, we actually do a lot of observation. We try a lot of obfuscation methods. So in terms of, you still get the trajectory of a trip, but you won't be able to know the exact origin destination of that. You won't be able to know where people start. You won't be able to know, the particular time stamp of that trip. So in the end,
the video even.
Yeah.
Right?
So after obfuscation of the data, it will become something like, oh, hey, here is a trip on a Monday in May and doing morning peak on an arterial road, in Bukit. So we have like a larger aggregated, information that people won't be able to trace the individual information, like personal identifiable information from the data. So that's one way. And usually these can be used, of course, after the data is collected. But I personally think, more importantly is actually to think from the beginning, when we're planning for a new tool, when we're doing design, like what Obsidian is doing, right? Like, and if we do privacy by design, if the camera itself is using like edge AI, if all the data processing is processed on the device itself and none of the raw data, images, footage or, disaggregated information is transferred or recorded, then you make it safer, in terms of privacy detection and also in terms of, I would say like the resilience in terms of like cyber attack. Because none of the personal information is stored, when data is collected. But of course, there's new problems that to say, if we are doing all these things on the edge, we need to make sure before we deploy that design, we need to make sure all the data we collected is validated. The methodology that we use is good in terms of getting all the data.
All the algorithm behind the scenes, if they are working properly, and that's why.
Exactly.
Living labs are actually a great opportunity for you to actually test those technologies before. We do have one, a big one in Peachtree Corners in Georgia, and that's exactly what they do. They test that in a safer environment, in a smaller environment, and then they can evaluate those risks up front, the cybersecurity risks, the privacy risks, and then the city will be able to choose based on what they can demonstrate there. And practical.
And also understanding, what level of details you want to actually collect from these data and to make sure, it's privacy protected, but also to ensure the level of detail is sufficient enough for, the actual usage of these data. And another thing that I like from, what you mentioned is now we have massive amount of data, right? It's not like the old times we're talking about, there's data gaps, I don't have such data. Now we're dealing with a new problem of I have too much data. And I'm not able to store all of the data, thinking about from agency perspective, because I used to work for New York City Department of Transportation, and I think, deal with big data. The problem is always about storage of data, how long we should store them. Is it making sense to store all of these information if, some of the information may not be useful? Are there like anomalies in the data, how we can deal with that? So I think there's always a new kind of like a research direction is to thinking about how we can more efficiently, extract the data and not collect everything, but only collect the critical piece of that. So one of our reason
only what you need.
Right. So one of our reason research is actually to look into, generative AI and to look at safety information from the video footage. And this is using a very similar approach, saying I'm not going to look at, each thing of the video. I'm only going to extract information when a risk, event is happening. If a car is almost running into a pedestrian, I want to know, when this is happening, how many times this is happening, what is the situation, when this type of near miss is happening. But you don't have to store, non-safety related data for that particular, goal of like improving safety or learning from the behavior of the participant. So I think that's also become a main challenge, but also a very interesting area of research in terms of how we can, with the limited label capacity, but now with, all these new technology like AI can automate a lot of things, how to better use the capability of this new technology. But also with the human, and in that loop, and to see, these are the most information that we collected, and also these are the most protected information if we want to share or use.
Yeah, I like that you mentioned people in the loop. That, for me, I think that is the expression of the interview. More often than not, when we are seeing these projects being deployed, the human aspect is being left out. Or sometimes they are mentioned, in the middle of the project, but bringing those actors to discuss that is important. But before we get to that point, I want to do a quick comment on the infrastructure to support all these technologies, all that data collection, all these huge amount of data that we have been capturing. And one of the problems is like there's so much telecommunication infrastructure that you can put in a city. There's so many competing technologies that are dependable on those carriers, are dependable on telecommunication infrastructure. And also when you are putting those hardware all around the city, there is always a concern where I'm going to put it. Does that going to look crowded? How most of the poles or street light poles in the city are owned or managed by utility companies. So there is another actor that you need to bring to the table to discuss. There is the communication technology that keep evolving that. But ultimately, public officials and new technology providers and academia now are on task. It's your job now to study ways to be more efficient, even though we have the ability to use AI, we have the ability, that has a built-in cost on that. Using things that are not so necessary, but you still want to get that just because, or being more efficient, more precise, more focused on to who we are building that up for, and is this person or this user in the loop? What are the other stakeholders that need to be involved? So that leads to my next question. When you were talking about these initiatives, engaging with different actors and sectors will be like a necessary thing, right? So how do you see the role of this cross-sector collaboration between academia, public agencies, and the private sector in advancing innovation in cities?
Definitely. So I actually have some great examples of past successful, collaboration that we were able to, successfully deploy. And one of the interesting example, I think, is, remember this physical test bed I mentioned on one of the highway in New York City, BQE, Brooklyn Queens Expressway. And we have a research project with New York City Department of Transportation and also with our industry partner to install weighing motion stations on the highway and to get information from overweight trucks. And the reason why this is very important, so this is really related to the real world and the very pressing challenge, is because there's a very specific section of the highway, which is a triple cantilever section. That is more sensitive and more fragile to, overloaded trucks, and because of, the superstructure and substructure of the triple cantilever section. And the infrastructure is aging, and unfortunately that is a widespread problem, in the entire nation of, our bridges and roadways need maintenance. Bridges usually have like a service life of 75 years, 50 years, depending on the structure. But with overlaid trucks, and with, like salt usage during winter season, that life might even be reduced. So, this successful example is, of course, this is a problem that, city DOT, state DOT is interested in, to say we have this aging infrastructure, we want to fix it. But before we fix it, we want to make sure there are no more, overweight trucks, which may bring extra damage and then expected or predicted, before their maintenance actions. And from the academia, we're like, we have all these amazing deterioration models, prediction models that we built for infrastructures with, with the appearance of overweight trucks. There's different, size of trucks, right? There's larger trucks, smaller trucks, and the damage that they may bring to the road infrastructure, to the pavement, to the bridge infrastructure. And then, of course, you have the player of the private sector of like, hey, we're a company and we have this amazing product of weighing motion stations, or commercialize off the shelf product that can be used to weigh the trucks, or to record the information of the overweight trucks. And through that research project, I think it's really a joint effort of all the stakeholders, every, sectors contribute and their knowledge and of, how this infrastructure is managed and how this overweight truck problems is managed and all the technology development, from the academia and public sector. And after the deployment of these sensors, for the pilot, for the testing site, in 2024 alone, I think there's a reduction of 60%, of overweight trucks on that particular segment. And ultimately, it actually supported the passing of the state legislation of an automatic enforcement of overweight truck. It is also the first in the nation, of such like automated enforcement of overweight trucks. So it's like in the end, you do see the safety benefit, you see the mobility benefit, you see the societal benefit, coming out from this collaboration, and it cannot be done without, the knowledge and from the academia partner, without the off-the-shelf product, from the vendor, and also more importantly, without the knowledge from the agencies, right? So it's really a very tight and, collaboration between everyone, and ultimately lead to a more, I would say, like speed up deployment of a new technology.
Thank you. Yeah, and do you see complications coming from that relationship between the private sector, public sector, and academia at some point, in one of your projects, if you can say?
I'm not sure if this can be shared, but I'm just kidding. I think definitely there are some, as I mentioned, there's some institutional, challenges, and this may not come from a separate sector. A lot of times it may come from, to say from the legal aspect of, you have this new technology, you have IP of that, and like university is willing to share the technology, but you have this issue of, of course, the technology has an IP with it. And the other thing I would say, it's always easy to test for a test site, but it will usually be much more difficult to scale up to the city level. And that actually, the role of the pilot test, pilot project is very important in most of the time, because this is the opportunity to see if the technology is actually scalable, right? Mm-hmm. And also to see what is the drawbacks, are there any data errors collected by technology? Do we have to do a second round of fix and, enhancement of the algorithm that is developed, or are there information that's incorrectly being collected? Because this can pass into a citation in the end, and you want to make sure everything automated by the system. And this related to the human in the loop thing. I think for critical outcome, it's always important for the decision makers and the developer, of the technology to be in the loop, to understand, these potential, limitations or errors, during the testing phase, before we scale up everything. So I think that's kind of a challenge across the nation. There's so many pilot projects that are going on across the nation, but how to scale it up effectively, cost effectively, and to avoid duplicated efforts is still an ongoing topic to discuss.
Gotcha. And I'm sure that there are also friction inside the own government, because there is sometimes disconnection between what the technical personnel is telling that they need and the political aspect of that. Yeah. So I think that is one common challenge that we see. You have never experienced that part on?
No, I mean, that's definitely something existing over there. And sometimes I think, there's always trade-off between, it's not necessarily the political aspect, but it can be a different aspect, from non-technical portion of it. And even to say with the end users, when we talk to the communities, you will see different voices from different people and from different units. If you're from the technology side, you want to make sure all the technology portion is deployed, right? But let's say from the financial side, we may think about more trade-off between like, oh, maybe I don't have to have 100% accuracy. If, 90% is sufficient to detect most of the things, will that be a more cost-effective effort? Or to say with limited budget, and there's always constraint, external constraints not related to the technology itself, but they're important aspects to be considered. So I feel like a trade-off always exists, and it really depends on what is the goal of, the project. Are we trying to save the infrastructure? Is a saving the infrastructure our, prioritized goal? Or to say, we might have a different, or sometimes like even within the same agency, you may have multiple units. It's like the weighing motion information, the station is installed for overweight trucks, but the data can be also used to like understanding truck flows, understanding general flow, understanding speed, right, on the highway segment. So there can be like multiple units within the same agency to use the same technology for different purposes. And for different purposes, you may have different prioritized, goals of that. So it's very challenging for sure, but sometimes I try to think from the good side. I'm like, it's also very interesting to think how we balance, all these different needs, and to find a way that hopefully can benefit everyone. And if not, at least, benefit some of, the users in it. It's definitely very difficult. But I think everyone still have this, pretty optimistic, and I would think like, it's a good opportunity to talk to each other as well, to understand if certain technology can be used for multiple users.
Absolutely. And you can see that how academia is so important in sharing that knowledge across different departments, across different cities even, and state officials and so on. So now I wanted to ask you about the other way around, right? How the cutting edge research and technologies and new approaches that are being researched and discussed inside the academia, how they can come out. I'm particularly interested in how can you transition research into actionable tools for government agencies and make that accessible and easy to use and easy to understand.
Definitely. So one thing I think from the academia, and this is something common thing that I see, is increasing the visibility of what we're doing. Because a lot of times I think, we're doing great jobs, but, if you're not able to present what you're doing to the related stakeholders, people are not knowing that, this group of people are doing this, amazing stuff, and there might be another university doing some similar stuff or slightly different stuff. And even like between university and university, I think it would be good for us to talk to each other. It's not like only like, talking to the agencies, to the vendors, but also talking between universities to understand what everyone is doing. And that visibility is very important to actually, to initiate the interest of, bringing these research product into, actionable tools. And the other thing, and that's from my own project experience, which I think is quite successful. And just as a tip is, I was doing this kind of like smart, transportation computer vision project. And I started off this idea of, what about let's bring in a voluntary advisory board? And I want to invite people from agencies. I want to invite people from, private sectors to be on the advisory board. And they don't have to spend a lot of time, but maybe, maybe 30 minutes every month, every 2 months, and just to be aware of, first of all, what we're doing, and also to provide some periodic feedback in terms of, is this making sense to you, right? If it's not making sense, then we're on the wrong track. And that's very important. And I think the periodic feedback, and remember also, things are changing. So like, you don't want to just collect like one-time feedback. Like the information I collected back to 2015 may not, be valid anymore in 2025, 2026. So it's very important to hear about periodic feedback from them and to see, is there something that you're interested and your current, maybe administration is prioritizing, but also more importantly, is this beneficial, for the actual end user, the communities in neighborhoods who might be, benefit from the technology. And for us, it's always good to refine or enhance, our approach based on these feedback. And also I think within that kind of platform, and it kind of facilitate an atmosphere in terms of like openly speaking about, what we are looking for. And it doesn't have to be like formal collaboration, but even like a casual talk of understanding what everyone thinks is very important, and can lead to the final, success of especially for like pilot, like testing new things, because there's a lot of uncertainties, a lot of unknowns in there. And by just one sector, like, people in academia, sometimes we may make assumptions that may not be, whatever the agency partner is looking for or the vendors is developing, but also it's information sharing with peers. So it's not saying we are the one who's learning, but also I think it's very good opportunity for, the industry partner, for the agency to talk to each other and learn from each other. So I think that's one of my approach that was successful in my project, but overall visibility, and also, as I said, pilot technology, like pilot program to test new technology is still one of the most efficient way to, test all these new things. And you will know if it's working or it fails, in a short run. But also it's a great opportunity to test if this technology is scalable, is transferable to a different city, by actually putting it in the real world, in the living labs. So that's definitely another, I would say, like, avenue,
so it's
to
prove
the success.
The initial concept,
right? So you want to have the proof of concept. You want to show, the initial evaluation of the effectiveness of the new technology, but you also want to look at, are there any limitations, are there any fatal limitations or, factors that needs to be, or like prerequisites that needs to be aware, like everyone, every stakeholder in the team needs to be aware before we can scale up, right, to the entire city.
Right.
And it would be too late if, we already develop a large program from the beginning and then you find, this is not working, at the first few months of the project. So pilot project is still one of the best approach of testing all of these, and good and bad parts.
I think the key is how are we going to turn the pilots into something scalable, but also sustainable for all the parties inside. Because when you talk about private sector and you have that startup struggling to put the product forward and then they are dying on pilots, it's extremely frustrating and it's extremely challenging. I wanted to commend you because you talk about all these complex projects, all these complex technologies, in such an accessible way, and thank you for that. I think our audience will appreciate that. I certainly do. And to conclude the interview, I would like to ask you, what are the 3 main things that our audience should know and should follow as they are doing their projects for cities in mobility and transportation and curbside management, specifically related, regardless whether it's a private sector or public sector, academia, what are your advice for our audience?
I don't know if I'm gonna have 3 things, but I can start. I think the first thing is, of course, don't be afraid of innovations. And especially I think in an era of, data, era of all the emerging technologies, there's sometimes hesitation in terms of, do I have the capacity to test new technologies? Will this technology work? Should we even start to trying that? Or, there might be a lot of debate. But thinking about, I think in this era, time is money,
Time is money first.
Right. So I would say, discussion and of course validation is good, but you have to try it before you can get a conclusion. So don't be afraid of testing out new things. It's definitely something, and I think one of the tips that I want to give to, every sector. Of course, academia, most of the times we're trying to stay at the cutting edge of new technologies, but within, everything of what AI is bringing to us right now, the changes can be by day, it's not in the past to say, I'm not expecting new things in years, right? Now you're like, next day I may have a new iteration of the large language model that people are testing. And no matter you like it or not, I think the change is happening. There will be this increasing usage of some of these emerging technologies. And I think especially for, as a researcher or as a decision maker, I think it's always important, and this probably is the second advice, is to stay in the loop. As I mentioned, there's a lot of new automation technologies that happening, but human's judgment is still the critical component of it. And I would say let the technology to support what we're doing, but don't let the technology to replace the human judgment, especially for critical outputs. And think about transportation, right? Transportation is the essential part of moving people and goods. Mm-hmm. And transportation is the essential part of moving, for emergency services, emergency repair of our infrastructure. And for all these critical components and for critical output, you still need human judgment and human knowledge, and in terms of making the critical, decision and validation, stay in the loop, is very, very important in that aspect. And the third tip, definitely we talk a lot about this collaboration, so I definitely want to come back to that. I think, coordinated policy development, strategy development, and from my aspect is still, super, super important. And talking to different stakeholders, don't stay within your own world of, only talking to your own people, and open widely to the avenues of, these are all the pressing needs, from different sectors. And these are the capability of, academia, of industry, of what we're doing, how to best match them, right? And, there's certain successful, I think project or program in New York City and in US. UTC program is one example that I mentioned.
UTC
for University Transportation Center program, from USDOT, and in terms of encouraging, the collaboration between agencies, universities, and industry partners. And there's also some other, I think, different effort that's being done. For example, in New York City, we have Vision Zero, research on the road annual event. We have Pilot City annual event. All these programs are facilitating the talk. Agencies pitch their ideas, industry pitch their product, and academics say, we have the label and capacity of doing, and of algorithm development or of helping everyone to get connected. And I think that's kind of the important pieces that will make all these coordinated policy decision making more informed, more evidence-based, decision making with the consideration of the limited resources we have in each sector and the pros and the advantage of, what each sector can provide. So that will be my last tip, for everyone who wants to conduct, project or making new product out of that.
Yes, I do encourage everyone in the audience to access the C2SMART website. Do you have that right now?
Yeah, that's basically www.c2smart. I think it's
NYU.
NYU.edu.
I'll put the right one. Thank you very much. It was a pleasure.
Thank you for inviting me.